Okay, here's our next video on best fit lines. Our learning target is learners will be able to write a linear equation of a scatter plot. So you're going to have a scatter plot, and then you're going to try to draw a linear equation based on that. When drawing our linear equations, we need to find the slope and the y-intercept to write it in slope-intercept form. Okay, here's how you're going to do it. All right, here's how to write a best fit line for a scatter plot. First, make a scatter plot of the data. So you take the table or the information, whatever data you have, and you turn it into your scatter plot. And then you decide whether or not a linear line would work. Some scatter plots have no correlation, so you would not be able to do that. But if it has a correlation, either positive or negative, you can then write a line of the scatter plot. So you're going to draw a line that appears to fit the data closely. Alright, so you kind of got to guess. You should have about the same number of points above the line as you do below the line. So when you're drawing your line, you kind of want to try to find it so that the points are split along that line. And then you want to write an equation using 2 points on the line. They don't have to be actual data points. They can be. So big things you want to look for are either going through 2 points or trying to go through grid lines so that you know the exact point. You're going to use any 2 points on that line, and that's how you are going to write your best fit line. Okay, I have 2 examples. Let's go get started on those. Alright, in our first example, showing injured birds. Okay, so here's our data. These are the years since 1995, so 2 years after 95, so 97, and so on, and how many birds the person rehabilitated at the veterinary service. Okay, so I'm going to graph my points, 1, 2, and then up to 8. So there's my first point, and then 3, 11. So I'm counting by 2s, so that's going to go there. 4, 12 would go right there. 5, 12. It's right there. 6, 15. So that's 14, 15 is right there. 7, 19. So 20 is right here, so it's going to be right under 20. And then 8 to 21. Over 1 and halfway up there. Okay, so there's my point, and I want to try to draw a line that best fits that data. So when I look at these, okay, I have a couple points up top and then a couple below. I'm going to try to draw. I'm going to draw a line. It's going to kind of come through here, like this. All right, that gives me 2 below, 2 above, and then 1 right about on. And it looks like this first point right here and that point, we're pretty close to me going through those lines. So I'm going to use those as my 2 points. So what are those 2 points? Well, I'm going to write them down. 2, 8, the first one, and then my third point, 4, 12. So those are the 2 points I'm going to use. That seems like that my line goes through there. Okay, again, there could be some little variation on these as you're trying to do them by hand. Alright, so first, just like we write equations, find the slope. So I want to find that slope first. 12 minus 8 over 4 minus 2. That's going to give me 4 over 2, which equals 2. Okay. Now I find my y-intercept. So I plug one of these points. I'm going to use 2, 8, in my equation. So I'm going to do 8 equals 2 times x plus b. 8 equals 4 plus b. I'm going to subtract 4 from both sides, and I get 4 equals b. So now I have my y-intercept, I have my slope. Here's my equation. Y equals 2x plus 4. Now I could use this to predict how many we could do in 10 years, by plugging 10 in for x. So I would anticipate that in 10 years they'd be able to help 24 birds. Okay, so you can use that information then to help predict the future. But like anything, at some point you got to max out. If I would put in 100 years from now, could a person do that there? Well, unless they change it, probably not, because the facility is going to be only so big. Okay, so that's how you do that. So again, you got to draw that, plot the point, draw your line, and then you got to write it. Find your slope, find your y-intercept. Okay, I'm going to move on to example 2. In example 2, okay, this is just some raw data here. Let's graph it. So tens, I counted by 5s. So this is 5, 10, and then up to 55. So that's going to go there. And then 20 and 45. And that's going to be right there. 30 and 45. Okay, 40 and 40. Okay, and then 50 and 35, so there's 25, 35, and then finally we have 60 and 20, which is right there. Okay, so again, this is a negative correlation, so now I got to try to draw my line, and it looks like if I kind of draw my line through the first and last point, that seems to be fairly good. I don't have 3 above and only 1 below, but I'm going through those 2 points, so that seems, maybe accurate. Maybe it could be a little bit higher. Maybe, maybe I could do it up to here, and I could draw my line coming through there, even though that's not an actual data point, because then that gives me 2 below and 3 above. I'm going to do that for it. So I'm going to forget this first line. I'm going to use this second line here. That's the line I'm going to use. I think that's a better representation of the line. It makes it not dropping down so much. So my 2 points are my first one, so that's 1055. And then my second one, which is 6025. I'm not using the 55 or the 20 they gave me. So there, that's a point not in my data, but I can still use it. Okay, so let's find the slope. All right, I'm going to do 55 minus 25 over 10 minus 60. It's a negative correlation, so it's going to be a negative slope. So that's going to give me 30 over negative 50. Okay, when I do that, that reduces to negative 3/5. Now I do my y-intercept. I guess I can write that to remind myself what I'm doing here. So I plug in y. I'm going to use 10 and 55. That seems maybe a little easier. So 55 equals negative 3/5 times 10 plus b. Okay, that's going to be negative 6 right there. So 55 equals negative 6 plus b. All right, then I'm going to add 6 to both sides, and I get 61. All right, and so there's my y-intercept. So now I can write my equation. So this would be y equals negative 3/5 x plus 61. And that is going to be what I think that line would be. So again, I could use this data to anticipate other points if I want to anticipate lower or higher values for x. Okay, so that's how you do the best fit line. Have a great night, and we'll see you later.